Did you know that around 2 million years ago, Earth was an entirely different place? Imagine a world where our early human ancestors roamed alongside saber-toothed tigers, mastodons, and giant rodents. And if that wasn't wild enough, the Earth was also in the middle of a deep freeze, with ice ages coming and going until about 12,000 years ago. Scientists have long debated the causes of these ice ages. Factors like the planet's tilt and rotation, shifting plate tectonics, volcanic eruptions, and carbon dioxide levels in the atmosphere all play a role. But what if some of these drastic changes were influenced not just by Earth's environment, but by the Sun's location in our galaxy? In a groundbreaking paper published in Nature Astronomy, astrophysicist Merav Ofer from Boston University and Harvard Radcliffe Institute uncovered some fascinating evidence. She found that around 2 million years ago, our solar system encountered an interstellar cloud so dense that it could have disrupted the Sun's solar wind. This suggests that the Sun's position in space might have had a more significant impact on Earth's history than we ever imagined. Our entire solar system is enveloped in a protective plasma shield, known as the heliosphere, which is generated by the Sun's constant flow of charged particles, solar wind. This heliosphere extends well past Pluto, creating what NASA calls a giant bubble that shields us from harmful radiation and galactic rays. This protective bubble is crucial for life on Earth. But according to Ofer's latest research, this dense interstellar cloud compressed the heliosphere in such a way that it left Earth and the other planets exposed to the interstellar medium for a brief period. Imagine that. For the first time, we have quantitative evidence showing that the Sun's interaction with something outside our solar system affected Earth's climate. Ofer, who is an expert on the heliosphere, has fundamentally shaped our understanding of this cosmic bubble and how it interacts with the space between stars. Using sophisticated computer models, Ofer and her team looked back in time to visualize the Sun's position 2 million years ago. They discovered that a dense cloud, part of the local ribbon of cold clouds, could have collided with the heliosphere. This collision would have exposed Earth to the interstellar medium, filled with gas, dust, and radioactive particles like iron and plutonium. Normally, the heliosphere filters out these harmful particles, but without its protection, they could easily reach Earth. Geological evidence aligns with this theory, showing increased levels of isotopes like 60 Fe and 244 Pu in ocean sediments, moon rocks, Antarctic snow, and ice cores from that time period. This also matches with records indicating a cooling period on Earth. According to Avi Loeb from Harvard University, our passage through these dense clouds could have exposed Earth to a much higher flux of cosmic rays and hydrogen atoms. This opens a new window into understanding the relationship between the evolution of life on Earth and our cosmic neighborhood. The impact of such events on Earth's climate is still being studied, but Ofer and her team are already looking to trace the Sun's position even further back, up to 7 million years ago. This research is possible thanks to data from the European Space Agency's Gaia mission, which is creating the largest 3D map of our galaxy. So this cloud was indeed in our past, and if we crossed paths with something that massive, we were exposed to the interstellar medium. The effects of this exposure on Earth's radiation, atmosphere, and climate are still being explored by Ofer and her team at BU's Shield Drive Science Center. This is just the beginning of understanding how our solar system's journey through space has shaped life on Earth. Stay tuned for more exciting discoveries.